Hello everyone, I am Kanika Sachdeva and today we are going to discuss about the chemical bonding. Firstly, we will discuss about the bonding in electrovalent, that is what is electrovalent bond, which is also called ionic bonds. Then we will discuss about the covalent bonds, and at the last we are going to discuss about valence shell electron pair theory. Here we will discuss about what are these bonds, their conditions and their formations. So coming on to first is electrovalent bonds. Now in electrovalent bonds we see that transfer of electrons occurs. Transfer of electron occurs. Electrovalent bonding is generally seen in a metal and a non-metal, that is the atoms which consist of this electrovalent bonds are usually of different nature, that is one has a tendency to lose electron and other has the tendency to gain electron. So we see that electrovalent bonds is generally seen in dissimilar atoms. Dissimilar atoms. Now how these occurs we will discuss in considering the example of NaCl. Now in NaCl, considering table salt, we have NaCl. As we see sodium, whose electronic configuration is 281, whereas chlorine, whose electronic configuration is 287. We see that here sodium is a metal and chlorine is a non-metal. Sodium has one electron in its outermost shell, that is it has a tendency to lose this electron, whereas chlorine has a tendency to gain this one electron, forming Cl minus after gaining one electron, and this sodium after losing one electron will form Na plus. So we will see transfer of electron. This electron is lost from Na forming Na plus, which is gained by Cl, which forms Cl minus. So this transfer of electrons occurs in such bonds and the compound form is NaCl, Na plus and Cl minus. We see there is electrostatic force of attraction in this following compound. Therefore, they are known as electrovalent compounds. Also, due to this formation of ions, they are good conductors of electricity. Now, we see that why sodium has lost this one electron. Now, as we know, in order to follow the octet rule, that is to gain stability, every element, every atom wants to have 8 electrons in its outermost shell. Therefore, sodium after losing this electron will have the configuration of 2,8, and chlorine after forming chloride will have the configuration of 2,8,8. Therefore, following the octet rule in both the cases. So this is how the transfer occurs and electrovalent bonds are formed. Now we will see what are the conditions that follows electrovalent bonding. Now we see that the conditions, the first condition is that the electronegativity. We see that if there is large electronegativity difference, then only these bonds are formed. As we see that NaCl, we know that Cl is electronegative than sodium, which is electropositive metal. Therefore, this forms the electrovalent bonds. So we see that usually there has to be a large difference in electronegativity for these bonds to be formed. Next factor we have that low ionization energy and high electron gain enthalpy is preferred. Now we will see what are these terms. High electron gain enthalpy. Now what is ionization energy? Energy required to lose an electron. We know that energy required to lose electron from a gaseous atom is the ionization energy. Now, the low is the ionization energy. It is more easily the atom will lose its electron. So low ionization energy is preferred. Now the next point is high electron gain enthalpy. Electron gain enthalpy is the enthalpy required when an atom gains an electron. So it should be high for an ion to gain electron easily. Now these were the conditions. We have seen the formation, we have seen the conditions. Now we will discuss about the properties. Now, as we have seen in our example NaCl, we have seen that Na plus Cl minus. The ions are formed in these compounds. So, due to the formation of ions, we see that they are good conductors of electricity in molten state. They usually do not conduct electricity due to the electrostatic force of attraction, but when they are in molten state, they easily carry current and are good conductors of electricity. Next, due to the electrostatic force of attractions between them, electrostatic attractions, we see that they have high boiling points and high melting points. These are usually soluble in protic solvents and insoluble in non-polar solvents. For example, NaCl, MgCl2, etc. Now we are going to discuss about the covalent bonds. We are going to discuss about the covalent bonds. The covalent bonds are usually formed between similar atoms or the dissimilar atoms For example, we see hydrogen, HCl, CH4. We will soon discuss the formation of these covalent compounds. These are usually formed by sharing of electrons. Now, why this sharing of electron occurs? Because there is no difference in electronegativity between the atoms. No difference in electronegativity is seen. Hence, these are formed by sharing of electrons. The bonds which are formed are known as covalent bonds. Now, covalent bonds do not acquire any charge. Since the electron is not lost completely, as the electron is shared and not lost completely. For example, H2, we see that hydrogen. Also, first, covalent bonds can be single bonded, double bonded or triple bonded. For example, H2, N2 which is triple bonded, O2 which is double bonded. Now we will discuss the example of first hydrogen, then we will discuss about nitrogen. Hydrogen, we see that hydrogen has one electron in its outermost shell. Similarly, another hydrogen, we will take it and having one electron in its outermost shell. So these electrons will form a bond by sharing of electrons, and both the hydrogen will have now two electrons and will follow the duplet, hence having the stability. So we see that this is how sharing of electron pair is between these H2. Now, considering the example of N2, we see that we have taken nitrogen along with another nitrogen. The configuration of nitrogen is 2,5. Now, 5 electrons in its outermost shell. 1, 2, 3, 4, 5. Similarly, 1, 2, 3, 4, 5. Now, first we'll see that these will be shared between, this electron pair will be shared between the two nitrogen. Now we'll check the electrons, that is 1, 2, 3, 4, 5, 6. Still the octet is not complete, so we will take another electron pair also. Now we will check 1, 2, 3, 4, 5, 6, 7. Now also we have 7 electrons, but we need 8. So we will take another electron pair which is being shared. Now we'll check it. That is 1, 2, 3, 4, 5, 6, 7, 8. Hence we see that now this nitrogen also has 8 electrons in its outermost shell. Also this nitrogen 1, 2, 3, 4, 5, 6, 7, 8 has also completed its octet, and hence triple bond will be formed between these two nitrogen. Similarly, examples of CH4 can be taken. Now we see that there are no ions. As there are no ions, these are bad conductors of electricity. Also, due to weak forces of attraction, they have low melting and low boiling points. These are soluble in non-polar solvents and insoluble in polar solvents. Now we are going to discuss about, so the shape of molecule will depend upon the number of valence shell electron pair around the central atom. Now this electron pair may be bonded electron pair or the non-bonded electron pair. The number of electron pairs will decide the shape of the molecule. Now we see that these pairs in valence shell repel each other. So the position of these electron pairs is such that they have minimum repulsion and thus the maximum stability. Now we see that lone pair repulsions are very higher than the lone pair bond pair repulsions, and then the bond pair repulsions. Now considering these factors, we have the geometries according to the number of electron pairs, which we will discuss. Now electronic repulsions between two electron pairs will be minimum if they are far apart. If they will be very far apart, so there will be minimum repulsion. Now we see that when there are number of electron pairs, we will discuss the number of electronic pairs 2, 3, 4, 5, 6 and so on, and the geometry along with their examples. First, if there are two electron pairs, the geometry will be linear. How it will be linear? For example, BeCl2. For example, we have beryllium, Cl and Cl. We have 2 electrons in its outermost shell of beryllium and 7 electrons in chlorine. So that 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6 and 7. It will share electrons. Now hence we see that this forms a linear structure when there are 2 electron pairs, 1 electron pair and another electron pair. Similarly, if there are 3 electron pairs, we have the arrangement that is trigonal planar. For example, BCl3, that is BCl3. If there are 3 electrons pair 1, 2 and 3. Now when there are 4 electron pairs, the geometry is seen as to be tetrahedral. For example, CH4, ammonia and water. For example, we have carbon, which has 4 electrons in its outermost shell, hydrogen, hydrogen, hydrogen and hydrogen, 1 electron, and hence this will form tetrahedral environment. In ammonia there is 1 lone pair and in water there are 2 lone pair. We will discuss it later how these lone pair will affect the geometry of this compound. Next, coming on to 5 electron pairs. Now when there are 5 electron pairs, we have the geometry as TBP, that is trigonal bipyramidal. For example, we have PCl5. Now how this forms? we have phosphorus, and in phosphorus we have 1, 2, 3, 4, 5. 5 electrons in its outermost shell, along with chlorine. These are the axial bonds, and these are the equatorial bonds. One, two, three, 4, 5. 1, 2, 3, 4 and 5. These are the axial bonds and these are the equatorial bonds. This forms the TBP geometry. Now coming on to, so here we can see that these are 5 electron pair. 1, 2, 3, 4, 5. Similarly, when we have 6 electron pairs, we have the geometry as octahedral, and the example is SF6. In sulfur, we have 6 electrons in its outermost shell and 6 fluorine, that is 1, 2, 3, 4, 5, 6. So this is the octahedral geometry. We can see that there are 6 electron pairs and hence the geometry is octahedral, for example SF6. Now we see that what happens when electron pair, the lone pair repulsion start occurring in a molecule. So we see that distortion of geometry starts occurring. For example, we have CH4. We know that CH4 has the geometry as tetrahedral. Ammonia also has the geometry as tetrahedral. Also, water also has the geometry as tetrahedral. This is also tetrahedral and this is also tetrahedral. But we see that here the bond angle is 109 degrees. Here the bond angle is 106 degrees approximately, and here the bond angle is 104 degrees. Now we see that when the geometries of three of them is tetrahedral, why there is variation in this bond angles. So we see that due to the presence of lone pairs, that is one lone pair in nitrogen, here in ammonia we have one lone pair, due to which its shape is pyramidal shape, and hence its bond angle is 106 degrees. In water we see that its shape is bent due to this two lone pairs which repel each other. Due to this repulsion of lone pairs, the bond angles comes out to be as 104 degrees. So here we see that when there are lone pairs in the molecules, repulsion occurs, and due to these repulsions, the molecule wants to gain maximum stability, so bond angle comes out to be different as that of CH4. So we can also discuss some more examples similarly. Now this was just an example of these molecules. So this was all for today. Thank you.